In this problem, I need to find the domain of the radical function f of x equals the square root of x plus 3. So by the domain, I need to know all the real input values or x values that I put into my function so that f of x, my answer, is a real number. Do we ever get non-real numbers out of the square root function? Yes. If the number underneath the radical is a negative number, then f of x will be an imaginary number, and I want to avoid imaginary numbers. So what we have to do is ensure that the radicand, the guy that lives under the square root sign, is either positive or 0. So the domain is when x plus 3 is greater than or equal to 0. So we have this inequality to solve. What's the degree? The highest exponent on an x is a 1, so it's a linear inequality. And what are the rules for solving linear inequalities? Well, we solve linear inequalities in one variable just like linear equations in one variable, except if you multiply or divide the inequality by a negative number, it's going to reverse the inequality symbol. And also, if you interchange the two sides of the inequality, that also reverses the inequality symbol. So we have to remember that when we solve our linear inequality here. I'm going to need to get x all by itself, so I'm going to have to subtract 3 from both sides of the inequality. Is that going to change the inequality symbol? No. So I'm going to subtract 3 from both sides, and I get x is greater than or equal to negative 3. So this is the domain of this radical function. And I need to write it in interval notation, so you sketch the graph first. So I'm interested in the number negative 3. I need x to be greater than or equal to negative 3, so I'm going to shade all the way to the right, put an arrow on the end, and since it has an equals here, I need to use a square bracket. So what does that look like in interval notation? It's square bracket negative 3, comma, infinity, but you can never put a square bracket on infinity or negative infinity, so I have to use a parentheses. So there's my answer in interval notation.